Signal starts from SA node, it takes 0.03 seconds to reach AV node and further 0.06 seconds to depolarize the atria. So total time for atrial depolarization, we are just adding this 0.06 and 0.03, it is 0.09 seconds. Since P wave is representing atrial depolarization, so this P wave duration is 0.09 seconds. Now impulse stops at AV node for 0.1 second, that is the AV nodal delay, and then only the ventricular depolarization starts. So if we add this, the travelling time 0.03 seconds and this 0.1 second, it comes to 0.13 seconds. That means from the beginning of the atrial depolarization to the beginning of the ventricular depolarization, it is 0.13 seconds. This is what? This is nothing but PR interval. Then ventricular depolarization, it takes around 0.03 seconds to occur from year to year, and then further spread by Purkinje fibers also takes 0.03 seconds. So again it is 0.06 seconds. So this QRS complex, see, it represents the ventricular depolarization, and we are seeing that ventricular depolarization is occurring in 0.06 seconds. Simple to remember, right? You have to remember only this 0.03 everywhere and AV nodal delay as 0.1 seconds, and you can easily tell how much is the duration of these waves and intervals. Now to calculate PR segment, you just minus PR interval from P wave and you will get the duration of the PR segment, that is 0.04 second. So basically you need to remember only two more values, that is the ST segment and the duration of the T wave. So ST segment duration is 0.08 to 0.12 second and duration of the T wave is 0.12 to 0.2 seconds. So when you know the duration of the ST segment and T wave, then you can easily calculate what will be the duration of the ST interval, right? That is from the end of the QRS complex till the end of the T wave is your ST interval. Just add the two durations and you will get the duration of the ST interval. Similarly, you can get also the duration of the QT interval. Now let's combine all this information and see how to read an ECG. Remember that when ECG is recorded on a thermal ECG paper at a standard speed of 25 mm per second, then each small square of ECG horizontally represents time of 0.04 seconds. Similarly, the calibration which we discussed in the beginning of the video about the voltage, each small square vertically represents 0.1 millivolt. So this 10 squares represent 1 millivolt. So one small square will represent 0.1 millivolt. Why it is important to know this? Because once you know the calibration and speed and how much each square represents horizontally and vertically, to determine the duration of each segment, interval, wave, you can simply count the number of squares. So suppose here P wave is having around 1.5 squares, so it will represent 0.06 seconds. And for voltage, you just count the number of squares vertically. So suppose here again it is around 1.5 squares, so it will be 0.15 millivolt. So for reading ECG, what we need to look at? So there are multiple things we need to look at. First thing is whether there is presence of sinus rhythm. That is, whether signal generated at SA node is reaching ventricles or not. So that we see whether every P wave is followed by QRS complex or not. So for this you take any lead ECG and you just see whether P wave is followed by QRS complex. Secondly, look at the waves. What is their shape, duration and voltages. Now voltages of the waves will vary in different leads. This we have discussed in some other video. Please check that out. The link for it is given in the description section. Why voltages of waves differ in different leads. But the duration will be same in all leads. So for checking the voltages, you see how it is appearing in different leads. Now before going further, we'll just see how to calculate the voltage of QRS complex. See, QRS complex is having a negative wave, then positive, then negative. So which voltage to take out of these? What we do is we take the voltage of the most positive wave. So from the baseline, in this case the most positive wave is R wave. So we will take from baseline and count the number of squares. So how much it is, say 5, 10, 11, 12. 12 squares, so it will be 1.2 millivolt. And the most negative wave. So out of this S wave and Q wave, actually Q wave is more negative. So we will take it as minus 0.1 millivolt, right? And we take a algebraic sum of these. So the voltage of the QRS complex will be 1.1 millivolt. Okay, then we have to look at the segments and intervals. What is their duration, whether it is normal or not. Now again, duration will be the same in all leads, right? So just count the number of the squares. So suppose I have to calculate duration of the PR segment, then what I will do? I'll just see the number of the squares. So in this case, number of a square is 1. So duration of the PR segment will be 0.04 seconds, because one small square represents 0.04 seconds. Next, we have to look at the SG segment and something known as the J point. J point is the point where QRS complex ends. In normal condition, if we extend our TP segment, so here comes the significance of the TP segment. So if we extend our TP segment back, it will coincide with the SG segment. Both will be in the same line. But sometimes this end of the QRS complex and this SG segment will be either above or below this line. This is known as SG segment elevation or depression. So that also we have to check whether there is any SG segment elevation or depression or not. Then next we have to look for the RR interval. Now this RR interval gives us information about the heart rate, and what we do is we count the number of the small squares between the peak of two R waves, and to calculate heart rate we use one formula, 1500 divided by the RR interval, where RR interval is represented in the form of number of small squares in between the two RR peaks. So this will give you the heart rate. Now this RR interval is used when the sinus rhythm, that is a normal rhythm, is present, that is P wave is followed by the QRS complex. But if sinus rhythm is not present, that means all P waves are not followed by QRS complex, so then in that case we use PP interval. So PP interval will give you the atrial rate if sinus rhythm is not present, and RR interval in that case will give you the ventricular rate. Now finally you have to look at the cardiac axis. Now cardiac axis represents the average direction of depolarization of the heart in one impulse. Now how much is normal cardiac axis and how to calculate it, plus what is the shortcut of knowing the cardiac axis, that we will reveal in another video. Well, thank you for watching the video. And